What's going on, you guys? Welcome back to the channel, and I have a super unique one for you today. As a lot of you probably know, Halo Infinite early released their multiplayer recently this past week, marking the 20th anniversary of Halo. And if you're like me, you probably grew up playing these games. So you know, on this channel, we do typically Python and other software tutorial series. We've done apps, we've done widgets, and we've done just base Python programming, as well as a few games. And I thought what would be super fun in honor of the Halo release is if we did a little bit of a Halo kind of Space Invaders style game. I'm going to start every video in the series by kind of demoing the game so that you guys see what the end goal is and hopefully think that that's something worth building to. So I'm going to demo the game that we built here a little bit, and I am pretty proud of it. You can hear just kind of the epic soundtrack in the background. I've left instructions for how to play and said, you know, click anywhere to begin. So let's get into it. We've got a little some soundtrack playing in the background. I've got some sound effects. The enemies in each wave are automatically spawned in, and they kind of randomly pick heights to spawn in from, and I've set them up with a specific speed to come in at. And I've added some impact sound effects that maybe aren't the greatest. I've also made it to where each wave increases the number of enemies, so you can see we're on level 2 now, and we should have more enemies. I got these little 8-bit Halo icons from the internet. And in the series, in the actual tutorials, I'll talk through kind of how to grab images, how to scale them all to the size that you want, as well as there's a free tool on the internet for removing the background from images. So if you've dealt with kind of the super annoying, like you pull in an image you want to use and you have that like white rectangle around it, no worries. We'll go over how to do that too.
Game over.
All right, so there we go. So that's the game demo, and whatever stage of the project you're at and following along with, hope you're enjoying it. Be sure to leave a like on the channel, a subscribe to the channel if you are enjoying it, and good luck with your code. All right, part 4 in our Halo Space Invaders Pygame Python tutorial series, and this episode is coming in. The enemies are already spawning in. The player's already built with 4-directional control, and at the beginning of a level, the enemies spawn in and they kind of rush at you, but you can't shoot at them yet. Nothing happens when they go off screen to the left, which means the level never increments. You don't lose any lives, you don't lose any health, nothing's happening. And to kind of get this game to the next step, we have to introduce projectiles, both the players and the enemies' bullets. So we'll say we're going to create a new class called Projectile. And if you think about what we have to give the bullet, what's going to be passed in this init function, it's going to be an X and Y location, just like with the player, and there's going to be an image passed in, just like with the characters, with either a player or an enemy. Okay, and so we're going to start with that for our init, and just like before, we're going to use self.x equals x, self.y equals y, and again, what we're doing here is we're creating internal variables that we can use that reference those things that are getting passed in the beginning. And since we are going to be checking collision just like with the players, we're going to want to set up a mask. So we'll say self.mask equals pygame.mask underscore from mask dot from underscore surface. It definitely would have been faster to copy this at this point, but from surface, and then the surface that we're checking against is self.image. So it's just like the character and the enemy that we created before. And then that's going to be it for the init. And then the draw function, obviously we need to put the thing on the screen. So just like the character, again, we're going to use a draw function that's just going to be window.blit, and then we're going to be putting the image on at our X and Y coordinates. So that should feel really familiar if you've been following along with the series. We've already got you know, that exact same draw function inside the character class, but because the projectiles are going to behave quite a bit differently, it doesn't make sense to use the character class as a parent class for these guys in the same way it did for player and enemy. Because like, so for movement on these, right, it's going to be all we have to pass in is speed, because wherever a projectile gets created, regardless if the player moves up or down or the enemy keeps moving to the left, all we're going to do is take where the character was when it shot, and we're going to move the projectile horizontally based on that. And so we're just going to do self.x plus equals speed. And the way we'll handle the fact that the player bullets move to the right and the enemy bullets are going to move to the left is we'll just use a negative speed for the enemy bullets and a positive speed for the player bullets. And that way we have two directional control. All we have to do is pass the correct, whether it's positive or negative, we have to just pass that in. And then we're going to check for the bullets if they're off screen or not, because that's when we're going to get rid of them. And so we'll just set this up to be a Boolean. So we're going to set this up to check true, false, whether or not a projectile has gone off the screen. And all we have to do there is we have to pass in the width of the screen. Okay, and so we could call a global and just check that variable, but it's a little easier to pass it in this way. And we're actually just going to return true, false, true if it is off screen. And so we're returning not, and then we're checking to see if the self.x, right, so the lower left point of the image, is between 0 and if it's less than or equal to the width of the screen. And so essentially, if it is between these values, right, 0 and the width of the screen, that means it's on screen. But if it's not, so this is super useful even if you have projectiles that spawned off screen to the right. You don't want them to be able to shoot yet. So if it creates a projectile while it's off screen, it's going to immediately get deleted because we're going to see that it's off screen. So that's the check off screen function. And then the last thing that we're going to create inside of our projectile class is going to be defining what a collision is. So it's going to just need to know what its target is, right? And this is going to be useful because for a player's bullet, the targets are all the enemies, but for an enemy's bullet, the target is the player. So it's going to be useful to know what the target is. And to do that, we're going to create a function outside of any of our classes that's going to be called collide, because we need to check if the players collide with each other. We need to check if the projectiles collide with the player, if they collide with the enemy, if they go off screen. So we're going to just return the result of collide between itself and the target. And so let's actually create that collide function that we just talked about. Essentially, it's just going to be checking for collision between two objects, object 1 and object 2. All right, and then inside, we need to check to use the mask function properly. We need to know how far apart their top left corners are, right? So if you think about the coordinate system in Pygame, how an image starts getting drawn from the top left, we need to know the gap between the x's and the gap between the y's, and then check if the masks collide. So maybe that'll make a little more sense once we get typed down, but essentially the gap of the x is going to be equal to object2.x minus object1.x. Okay, so think of like a I think it's the Pythagorean theorem, but we're actually checking the linear distance between these 2 points, but we need it for the mask overlap function in Pygame. So once we get through it, it's going to make a little more sense. Okay, so there's our gap in the x direction. Gap in the y direction is going to be just the same, except it's going to be dot y instead of dot x. Object2, object1 dot y. Okay, and here's why we actually needed it, because now we're returning a true false to see if there's been a collision. And what we'll be saying is object1 dot mask, and that should work just fine because everything that we've created that we're checking for collision for has an attribute that is dot mask. And now we're checking dot overlap. So this is the Pygame built-in function where it needs to know what the second mask that it's checking against is, and that's going to be object2 dot mask. And then it's asking for the difference in their coordinates. So here's why we need that gap x and that gap y. Okay. And then let's go ahead there and there. And now we're going to say is not equal to none. So what's important here is we're actually just checking to see if there is an overlap. We don't really need to know what it is. And that's why we do not equal to none, because this is actually going to return an X and Y coordinate of where the overlap is. That doesn't really help us for this game. So essentially, if the point of overlap is anything, if it's not non-zero, so if you have the very top of it colliding or the very bottom of it colliding, we don't care. So we're just checking a true false to see if they collide. And so we're just checking to see if it's not equal to none. And if it's not equal to none, then we'll get true back. And so this is useful. This is actually something that we're going to use inside of our player and enemy class now. So let's go ahead down into our character class where we had just the init and the draw defined before. And we're going to start adding some stuff here. We're going to add shoot to it. So let's go ahead and create the shoot function, because the player and the enemy is going to have shoot ability. And so we'll say shoot self, and what we're going to do is say if self dot cooldown time. So we need to set up the cooldown timer, because we don't want you to be able to infinitely shoot, right? So I'm going to change this self.cooldown that we threw in before. I'm going to change that to cooldown time. So right when the game loads in first, you're going to be able to shoot. But then once you've shot, we're going to create a timer that's going to say until you can shoot again. The enemy's going to have this as well. But if the cooldown time is equal to 0, and then the next shot is something we're going to load in. So essentially we're going to create the next bullet, and as you're shooting, we're going to keep track of all of your shots in a list for an enemy or for the player, because when an enemy gets destroyed, we also want all of their bullets to go off screen. So next shot is going to be equal to that class we just made of projectile, and we're going to give it self.x and then self.y and then self.shot. That's going to be the image, right? We already decided inside of the character class what the shot image is going to be. And so yes, we will need to add this inside of the player and enemy class, but all we're going to do is pull in the init from the shoot as well. Okay, so then we're going to do self.shots.append the next shot. And then we will set self.cooldown time equal to 1. All right. And let's create a little function that's going to use that cooldown. So we will just call this cooldown. And what we're saying is this is how we're going to track whether or not the player or the enemy can shoot again. So if self.cooldown time is greater than or equal to self dot, and now let's create the variable that's actually going to be how frequently you're allowed to shoot, the maximum time. And so we're going at 60 frames per second. So if I use a cooldown of 20, that means you can shoot a maximum of 3 times per second. This is another great place to fiddle with and see how it affects the difficulty of your game. This is all relative to your FPS. So remember, we have 60 FPS. This will be incrementing once per scan, and so that means it'll update 60 times per second. So if you're just holding down spacebar to shoot, you'll be able to shoot a maximum of 3 times per second with a cooldown of 20. Making that 30 would be twice per second. If you lowered that to 10, you'd be able to shoot 6 times per second. So play around with that a little bit. See how you want to do it. I'm going to leave it as 20. I kind of like the way that plays. But what we'll say is, if cooldown time is greater than the cooldown, then we're going to set cooldown time equal to 0, meaning you're good to shoot now. And then we'll do an elif, and if self.cooldown time is greater than 0, then we're going to increment it until we get to that cooldown time. So essentially what we're saying is, if it's greater than 0, which is what happens when you shoot, we set the cooldown time equal to 1, then just increment it until you get to the point where you're at the cooldown or higher than it if you've scanned twice and haven't executed this. And then as soon as that happens, you go ahead and set the cooldown time back equal to 0. Okay, and so that will handle cooldown. And then the next thing we're going to want to do inside of a character or a player is we want to move the shots. And the reason we're going to put this inside of the character class is because the direction is going to be different if you're a player or if you're an enemy, right? So we're going to say self. We're also going to give it a speed and a target. Because for the enemy, the target is the player. For the player, the target is the enemy. We'll give it a speed that we'll call like projectile speed, but you could make it to where the player shoots faster than the enemy if you wanted to. Okay? But in either case, we're only going to move the shots as often as we check the cooldown timer. So this will be where we call the cooldown function. It's nice to just have the cooldown only execute if there are shots on the screen. So there's no need to move shots or check for a cooldown timer if you haven't shot at all. So this is a good way to limit the processing power of your game. But we'll say for shot in self.shots, which is our list of shots, right? We are going to do shot.move. So in our projectile class, we set up that move. And so we're doing a lot of self-referencing of functions that we've already created. But this is way easier than doing it all outside of the class for player, for enemy, for every single projectile. So if it seems like we're stepping on our own toes a little bit, it's actually because we wrote the code in a pretty smart, pretty sleek way. So it's going to work pretty well. But we'll do shot.move at the given speed. So again, we're going to pass projectile speed in here when we create these. But then we need to check if it's off screen, right? Because that's when we get rid of it. So if shot.off screen, and we can just leave it like that because it's checking to see if it is off screen and it's a true false that it's returning. So if it's true, then what do we want to do? We want to self.shots remove that shot. So once it's off screen, get rid of it. There's no need to keep it on. And then we'll check elif shots dot, let me see, shot dot collision. So now we're checking for collision with the target. Collision, spell it right. And if the shot has hit the target, then what we're going to do is say target.health minus 10. So this one is going to get tweaked a little bit and we're going to remove the shot just like before, just like up here. This one's going to get tweaked a little bit for the player class because we're not just going to remove 10 from the health. We're actually going to have the player, when he hits the enemy, kind of one-shot the enemy. You could leave it this way and make it to where it takes multiple shots to kill your enemies. That's definitely like the way you would handle a boss fight or something like that. But this is going to be for all of the enemy shots that hit the player. And we're just going to modify it slightly inside of the player class. So I'm going to copy this whole move shots function that we just made. I'm going to come down inside of our player class, and I'm going to copy the whole thing in here, and we're just going to start taking a look at how we need to tweak it. So it's true just the same that we need to move every shot that you've shot. We want to check if it's off screen and remove it if it is, but then we'll do else, and we'll say for target in targets, because the target is actually going to be a entire list of targets for the player, whereas all the enemies are only shooting at one target, the player. It's just singular. But in here, it's actually going to be targets, and we're going to pass in the whole list. Okay, so it's going to be for target in targets if shot.collision, and so we're checking for collision with every individual target in a for loop. But if they collide, then what we want to do is remove that target from targets. So remove targets.remove that individual target, and then we are going to also remove the shot. So hopefully that makes sense. I know I went through it kind of quick, but the biggest difference between the player shooting is when it hits an enemy, we're going to immediately remove that enemy. Whereas if an enemy hits the player, it's just going to do 10 damage off the player's health, which we made 100. You can tweak with how much damage it does and make the game a little more unique if you want to change it up. But that's what we're going with here for the start of it. So, okay, that was a lot of writing code to get to this point, but now we've set up the projectile class and kind of the functionality behind it. So let's go ahead and actually create some projectiles, okay? So while running, let's go to all of our main loop functions. I'm a little too low here. Window.blit up here. Wave size equals 5. And let's make projectile speed a little bit faster than the player or the enemy moves. And we'll say projectile speed equals 6. We'll bump the enemy speed back down to 1. Now there should be shooting and actually clearing out of the map. We don't need them to move quite so fast. And let's go ahead and update if game over, if while running. Here we go. Okay, so let's go down to where we create our enemies, and let's handle, we already have a for in range of wave size where it creates the enemy, and then we add them all to the list, and then down below we say for enemy in enemies, move the move by whatever speed we gave them. Let's also do enemy dot move shots, and then we'll say move those shots at minus the projectile speed. So if you remember, we said when we were creating this, I know that was a while ago now, but we said the enemy shots are going to need negative speed and they're going to need to be targeting the player. And that's because they're moving from right to left, so we need to be subtracting 5 per scan or 6 per scan, whatever we made the projectile speed. But then let's make it a little bit randomized for when the enemy is going to shoot as well. And we'll say for random range 0 to, and here's where, again, the frame rate is going to matter. I'm going to say 0 to 180, which is essentially picking a different number in that range per scan. And I'm going to say equals to 1. So in theory, this should be shooting, every enemy should shoot at some random point approximately every 3 seconds. Okay, and so we'll say if that's true, then let's do enemy.shoot. Okay, and then we'll also say if the enemy.x, if they go off screen, so that'll be enemy.x less than or equal to 0, then we're going to subtract 1 of the lives, and we'll also remove the enemy from the enemies list. Okay. So now we're handling actually getting rid of enemies in the various different ways. And then the last thing we're going to do down here is we're also going to move the player's shots. And here we'll give it positive projectile speed, projectile speed. And we're going to say the target is going to be the list of enemies. And the last thing we need to do is we need to include the space. So if active keys, just like before, and now we're checking for pygame.k, and this is going to be k space. And if that's true, all we have to do is player.shoot. So you see, we wrote a lot of code on the front end. It did a lot of thinking and designing on how do we use the similar code between the player, between the enemy, and everything. But then when it comes time to actually assign it, it's relatively simple code. So we stuffed a lot in here really quickly, but finally let's run this and see if we're shooting, if we're able to get rid of the enemy. Let's see. Pygame mask.surface. Argument 1 must be surface. Let's take a look at what we've done. So a bit of troubleshooting there, but the problem is we said self.sht, which could be any SHT word, which is not good, but that needs to be self.shot. That's why it was saying that when the enemy was shooting, it said that its type was none because we never defined it. So you can see now we are able to load it up, and but we spelled something else wrong. We said Kalissan. So you know, this I've made a few jokes about while I'm typing. When I'm doing these tutorials, I try to go pretty fast and I talk a lot, which leads to some typos. So that's the sort of thing you run to do your troubleshooting. And let's see now. So I can hit the space bar, and I can actually shoot the guys and I can get them deleted off the screen, but we don't see the bullet. So let's go ahead and take a crack at what's going on here. Okay, so the reason the shots were actually active and taking out enemies, but we couldn't see them. We have to add a spot to actually draw the projectiles onto the screen, which we missed when we were doing all our initial code. And what that's going to be is 4shot in self.shots, which is the list in which where we're keeping track of all of our shots. We actually need to call the dang draw function and put them onto the screen. So I think that's all we missed. Let's go ahead and take a crack at it now. And we can see the bullet. I'm going to go ahead and hold down the space, and we can see, yeah, it's shooting at our at about 3 shots per second, which was our cooldown. Let's see real quick if I can get all of the enemies that have spawned, and let's see if our level incrementer is working properly, and then the next wave that spawns should have 5 more enemies. Try to dodge their bullets too. All right, so we're on level 2. Let's take a crack at this and see how many. I'm going to go ahead and get hit a few times, and we can see it deletes the bullets off the screen, but we haven't put any like game over conditions in yet. So in theory, I'm going to be able to take so much damage that my health goes negative, and it's not going to do anything. But you can see we lose a life when an enemy hits the left side of the screen, which is great. Again, we haven't put the game over checker in yet, so lives can go negative. If I were to leave this playing, it would just get up to infinite levels and spawn more and more enemies, and I would get ridiculously negative scores. My health would be super negative. So there was a ton of content in this video. I really appreciate you guys bearing with the tutorial, bearing with me through the troubleshooting, and we're getting really close to a full functioning game. So I hope you've been enjoying it. If you have, please leave a like on the video, subscribe to the channel. It helps me out a ton. And let me know what you want to see next in the comments below. Be sure to keep a lookout for the final episodes in this tutorial series. And as always, good luck with your code, and thanks for watching. Thanks. Bye.